Hey, and welcome back to another Make Math Make Sense Master Classic Math video. Today we're in the Algebra 2 course in the Polynomial Factorization unit. We're going to cover factoring polynomials common factor. If you're new to the channel, please hit the like button if this video is helpful to you. It's obviously good feedback for me, and it helps me make better videos going forward. Alright, let's go ahead and get into this first example. The rectangle below has an area of 6n to the 4th plus 20n to the 3rd plus 14n squared. The width of the rectangle is equal to the greatest common monomial factor. What is the length and the width of the rectangle? So this looks familiar, and it should, because in the previous unit we were given the length and the width and we found the area. Now we're given the area and we're having to work back. So we're trying to figure out what were the two expressions that we multiplied to get the area. So now we're working backwards, and that's when you work backwards from things that are being multiplied. That's called factoring. So we're factoring today. All right. The directions gave us something really important to know. It said that the width must be the greatest common monomial. So we know that the width is going to be the GCF. And we know that it's going to be a monomial. It's only going to be one thing. Right? Mono means one, which means that the length is going to have three parts to it, thus making it a trinomial. Okay, and we know that it's going to be a trinomial because our expression is a trinomial, right? We've got three parts to this polynomial. It's a specific polynomial. It's a trinomial, meaning there are three terms. There are three things being either added or subtracted. That's what that means. So we know that this is going to be some trinomial. Cool? And we know that this is just going to be a monomial. Alright, the very first thing we're going to do here is we're going to find the greatest common factor of those three numbers. So 6, 20, and 14. If we factor them out, for 6n, we get 2 times 3 times n times n times n times n. For 20 into the third, we get 2 times 2 times 2 times 5. Times n times n times n. And for 14, we factor this all the way out to its prime factors. We get 2 times 7 times n times n. Cool? So this is how we factor them all out to their prime factors. We're looking to see which ones they have in common. What's the greatest that they have in common? They all have a 2. So that looks to be the largest number that we can divide them by. We can divide them by 2. So we know that the width is going to include a 2. And then the variable portion here is like how many n's do they all have in common. So they all have at least 1. And looks like we can factor out 2 because they all have at least 2 being multiplied. So we technically could divide them all by at least 2 n's. So n squared. When I say 2 n's, I mean 2 n's that are being multiplied, right? Because they all have at least 2. And then the remaining portion is the length, and so that's just like what's left after we factor out that 2n squared. So one way is just take 6n to the 4th and divide it by 2n squared plus 20n to the 3rd divided by 2n squared plus take 14n squared and divide it by 2n squared. And then whatever we get left would be the length, right? But because I've written it out like this, I can see that, okay, there's a 3 and there's 2 n's left. So in the first term, we have 3n squared, which would be the same exact thing if we divide it, right? 6 divided by 2 is 3, n to the 4th divided by n squared, subtract the exponents, 2, right? 5 times 2 is 10, and we've got an n, so 10n. And here we just have a 7. So if you write it out like this with your prime factors, then the remaining things after you take out what's in common would be what's left over. Okay, and so if this down here wasn't clear, again, if you don't set it up like this where you factor, you find the prime factors of each term, once you find the greatest common factor, just take the greatest common factor, divide it by the area, and that'll give you the length. So this would have divided out to this right up here. Go Question number 2. Factor the polynomial by its greatest common monomial factor. So we're doing the same thing we just did. We got 6x to the third, which we know is the same thing as 2 times 3 times x times x times x. We've got positive 8x squared, which the prime factors would be 2 times 2 times 2 times x times x. 2 times 2 is 4 times 2 is 8, yeah. And then we've got negative 4x. The prime factors here would be 2 times 2 times negative 1 times x. Okay, and so let's just figure out what the prime factors are here. The greatest common factor, they all have a 2, so we can divide a 2 out of all of them evenly. And they all have at least one x being multiplied, so we can factor out an x. Can't factor out x squared because this one doesn't have another x, right? So that's the greatest common factor. And then the leftovers, let's call it leftovers, or the length, right? This is technically the length portion. For the first term, we would have 3x times x would be 3x squared. And then our second term would be 2 times 2 times x. 2 times 2 is 4, so positive 4 times x. And then our third term for the trinomial is 2 times negative 1, which is negative 2. And that's it. There's no x. And so then all we have to do is like put these two things together. Cool, that's pretty easy. We're just multiplying them together, so I'm just gonna actually type it in. So we got 2x times 3x squared plus 4x minus 2. Boom, done. Alright, I'm just gonna do this one a little bit differently. So first step is to find the GCF of 3, 15 and negative 18. And the GCF is a positive 3. Okay, cool. So we got a positive 3. We know that we're going to have parentheses. And then we got to look at the variable portion, right? How many b's do they have? Do they all have in common? This has 5, 4, and 7, so they all have 4 b's in common. So we can factor out a b to the 4th. And now I'm just like, what's left in the parentheses? It's like, okay, what number times 3 gives you all these like terms left. Like it's just the leftovers, right? So 3 times 1 would give us 3, and then b to the 4th times b would give us b to the 5th. 3 times 5 would give us 15. And this has 4 b's, so there are no b's left over. Oh, this is minus. 3 times 6 would give us negative 18. This has 4 b's being multiplied in, so we would need 3 b's right here to have 7 b's. Boom, done. Okay, let the greatest common factor be the width, right? So greatest common factor between those two terms, 30, 6, the largest number that we can factor out is a 6. How many k's do they each have? They each have at least 2. And what's left after we factor out a 36k squared from 30k to the third? Well, there's going to be a 5. 5 times 6 gives us 30, and then we're going to need another k to get to the k to the third. Plus 6 times 1 would give us 6, and then 6k squared times 1 would give us 6k squared, so it's just plus 1. And that's how you factor polynomials with a common factor. If the video makes sense, like it. If it doesn't, maybe give it a down thumb. I don't know. Please don't. But if that's the way it is, that's the way it is. Good luck.